Hello friends, we are back with our new video. In this video, I will discuss how to draw a bivariate continuous function or a heat map in R or R Studio using ggplot2 that you can use for your official presentation or in your publication. Please visit our website statswithR.com for more details. And if you have any queries, shoot us an email at learnstatisticswithr@gmail.com. The overall process involves several steps and I will discuss stepwise. Let's begin. As an example of a bivariate continuous function, we consider the bivariate normal density function with means of the two components to be 1 and 2 respectively. Their standard deviations are 1 and 1.25 respectively, and the Pearson's correlation coefficient between them is 0.5. Once you learn how to draw it, you will be able to draw the density function, cumulative distribution function, quantile function, survival function, etc. of any bivariate continuous random vector or any type of heat map. Here I consider one way to draw the heat map that I feel the simplest, but of course there are other ways to draw this in R using ggplot2. First, we form the mean vector mu and the covariance matrix covmat. The diagonal elements are sigma 1 squared and sigma 2 squared, and the off-diagonal elements are the same and equal to the Pearson's correlation times the product of sigma 1 and sigma 2. Once we run the code, the mean vector mu and the covariance matrix covmat are ready to use. Next, similar to a univariate continuous function, here also we choose a grid around the mean, except that we need to choose it in two directions. For choosing the range of the grids, we consider 3 sigma limits similar to the univariate case. Also, we choose the lag between the two consecutive points to be very small. For example, we set it to 0.05 here. Okay, once we run the first two lines, the two grids x and y are created. Further, to form a set of coordinates from this, we use the function expand.grid. This creates 2D coordinates, and the number of such coordinates is the length of the grid x times the length of the grid y. We store these coordinates into the matrix log. Next, we need to calculate the values of the bivariate normal density at all these coordinates. So, we use the function dmvnorm from the package emdbook. To install this package, we use the functions install.packages and library. Then we use the function apply to evaluate dmvnorm over the rows of log. Each row of log is a coordinate. Because of the row-wise operations, we set the margin to be 1. Once we run these lines, a vector norm to dense will be created. The number of elements in norm to dense is equal to the number of rows in log, and each element is the bivariate normal density evaluated at a coordinate. From now on, we just need the matrix log and the vector norm to dense. Before we move to create the ggplots, first we need the package ggplot2. So we need to install it and call it into R or R Studio. For this, we use the commands install.packages and library, similar to the installation of the package emdbook. Once we run the codes, we are ready to create the first ggplot. In the console window, type ggplot a blank bracket plus geomtile within aesthetics x equals to the first column of log, y equals to the second column of log, and fill equals to norm to dense. Now press enter. Okay, you get your first bivariate normal density plot. There are many things to change. Let's do step by step. First, although the range of the x coordinates is 6 times sigma 1 and the range of the y coordinates is 6 times sigma 2, and hence the ratio of the ranges of the coordinates should be sigma 1 divided by sigma 2. The plot doesn't automatically select this aspect ratio. To fix this, add the line coord fixed ratio equals to 1. Now press enter. Okay, you get your second bivariate normal density plot. Now the ratio of the ranges of the x and y axis is sigma 1 divided by sigma 2. Next, note that there are many horizontal and vertical lines visible within the plot, and the actual coordinates just appear as separated pixels. To fix this, within geomtile outside aesthetics, add width equals to a small number slightly larger than the legs we choose, that is 0.05. For example, we choose 0.06. Also set height equals to 0.06. This makes the tiles slightly larger both in height and width so that the gaps are no more visible. Now press enter. Okay, you get your third bivariate normal density plot. The plot looks very smooth now. The horizontal and the vertical lines are no more visible. Next, note that the axis titles are just the columns of log. Suppose you want to change the x-axis label to x1 and y-axis label to x2 to denote the components of a bivariate random vector. To do that, add the line xlab within expression x, then 1 within a square bracket, plus ylab within expression x, then 2 within a square bracket. Now press enter. Okay, you get your fourth bivariate normal density plot. You can see that the axis titles have changed. Next, suppose we want to add a title that explicitly writes all the parameter choices, initiating with the density of bvn. Here bvn stands for bivariate normal. Also, maybe you want to set the title at the top center. To do that, add ggtitle within expression, paste all the characters you want. The Greek letters along with the subscripts should be outside quotes and the rest should be inside quotes. Also, add space inside quotes if you want. At the end, add sep equals to a blank quote. This determines how you want the components within paste to be separated. This whole line creates the title. Next, add another line theme plot.title equals to element text hjust equals to 0.5. This sets the title at the top center. Otherwise, the default is left alignment. Also, note that we are storing everything so far into P0 for convenience and will add the subsequent layers on the top of P0. Now press enter. Okay, you get your fifth bivariate normal density plot. You can see that the figure title is created now and also it is at the top center. Next, note that the axis titles and the plot title are quite small. To enlarge them, add the line theme axis.text equals to element text size equals to 15. This increases the font of the axis. Axis.title equals to element text size equals to 15. This increases the font of the axis titles. and plot.title equals to element text size equals to 18, this increases the font of the plot title. If you don't need one or two of them, you can remove those lines. The larger the size you want, you need to fix a larger number. So choose a number accordingly. Now press enter. Okay, you get your 6th bivariate normal density plot. You can see that the titles and the labels are larger now. Next, note that the colors vary between dark blue through white, and the intermediate labels are not very clearly distinguishable. To fix this, you might consider to use the Viridis color palette. To do that, first we need to install and call the package Viridis. Then add the line scale fill Viridis, a blank bracket. Now press enter. Okay, you get your 7th bivariate normal density plot. You can see that the colors are replaced by the Viridis palette. We choose the default. There are multiple Viridis palettes available, and so choose accordingly. Next, let's focus on the legend. The title is just the name of the vector norm to dense, and also it is small. So you might be interested to change this title along with enlarging it. Besides, you might want to place the legend title at the top center of the legend. Also, the numbers 0.05 and 0.10 on the legend are very small and you might want to enlarge them. Suppose you want to change the legend title to density. To do this, first add name equals to density within quotes. This adds the title. Then within theme, legend.title equals to element text size equals to 18. This enlarges the title. H just equals to 0.5. This sets the title at the top center of the legend. And add another line within theme, legend.text equals to element text size equals to 15. This enlarges the numbers 0.05 and 0.10. Now press enter. Okay, you get your 8th bivariate normal density plot. You can see the changes you wanted. The title and the texts of the legend are large. The legend title has changed and also it is at the top center. Next, note that the legend key, that is the rectangle of the legend, is very small and you might want it to be large and proportionate with the figure. To do that, add legend.key.height equals to unit 1.5 cm within quotes and legend.key.width equals to unit 1.5 centimeter within quotes. This increase the height and the width of that rectangle respectively. If you want a different size, choose the numbers accordingly. Now press enter. Okay, you get your 9th bivariate normal density plot. You can see that the legend is large now. Next, note that there is a large gray region around the plot and you might want to remove it. To do that, add the line scale x continuous expand equals to expansion mult equals to a vector 0, 0. This removes the extended areas on the x direction. And similarly, also add it for scale y continuous. That removes the extended areas on the y direction. The defaults are 0.05. Now press enter. Okay, you get your final bivariate normal density plot. You might consider this plot for your presentation or in your publication. Here we consider a bivariate continuous function. You might be interested to draw a bivariate discrete function as well. To learn how to do it, watch our video How to Draw a Bivariate Discrete Function in R using ggplot2. If you found this video helpful, please like, comment, share and subscribe to my channel and press on the bell icon for more updates.